On Earth, lightning creates thunder that shakes windows and blinds you as it flashes through the sky. But what makes lightning, and can it happen on other planets? To figure this out, we need to understand electric motors and lightning storms. To change phases of matter, water either gains or loses energy. To freeze, the water loses energy, and to evaporate, it gains energy. Mostly in the form of photons from the sun. This is why there are more storms during the summer seasons when it's hottest outside. The water evaporates more often, leading to more frequent and larger storms. Once a vapor, the water rises into the atmosphere on convecting air currents. There, the water condenses back into liquid form, which we see as clouds. This is also why there's turbulence when planes fly over clouds. The water gives off thermal energy as it condenses, which makes turbulent air. Energy can't be created from magic, so generators like those in wind turbines or hydroelectric plants turn motion into electricity. Generators do this by spinning coiled wires in between magnets. Lightning storms work on the same principle. Although the process that creates lightning is largely unknown, we do know that like the magnets in a motor, the tops of storms can have a net positive charge, and the lower parts a negative charge. Lightning storms aren't just stationary and unchanging though. They naturally flow and move with the air currents in the atmosphere, and the storm isn't the only thing moving. Most of the water in a lightning storm rains down, but some of it can convect inside the clouds. And if a storm is big enough, the water can freeze and thaw multiple times as it spins around. So, lightning storms have a negative and positive charge with spinning water carrying electrons between them. But then, why does lightning ever strike the ground? Objects underneath storms are normally positively charged, so when enough charge has built up, the electrons surge between the cloud and the ground. It's this movement that we see as lightning. A bolt of lightning can reach up to 27,760 degrees Celsius. So, when lightning strikes the ground, the air around the bolt expands outward, leaving a channel around the lightning with almost nothing inside it. But after the lightning is gone, the surrounding air rushes in with such force that the sound wave made can be heard about 40 kilometers away. Another way to think about thunder is with a popped balloon. Once popped, the high pressure inside the balloon rushes out, leaving a gap with almost no air inside it. So, the surrounding air rushes back in, producing a sound wave. Regular lightning storms aren't the only way to make lightning. Erupting volcanoes can make lightning from colliding ash and soot particles that create a static charge. Lightning doesn't just happen on Earth, though. But on Mars, there isn't enough water vapor for lightning storms to develop. So any lightning there would get its charge using static and dust clouds, just like volcanoes. Thousands of miles away, the Pioneer Venus orbiter found Whistler signals in Venus's atmosphere that came from lightning. Images from Voyager 1 found lightning that formed inside a turbulent part of Jupiter's atmosphere near its pole. 6 years earlier, in 2004, Cassini also detected radio waves from a lightning storm dubbed the Dragon Storm, which continued for many weeks as Cassini orbited around it.